Well, all right, here we go. Rational functions. So you've actually worked with rational functions before. You might have just not realized it. Rational function is a function of the form r of x equals p of x all over q of x, where p and q are polynomial functions and q is not the zero polynomial. So I had a lot of students ask me, what's the zero polynomial? That's just the polynomial 0. So like q of x equals 0 would be the zero polynomial, right? So shouldn't be any surprise. We don't want the denominator to equal 0. The domain of a rational function is the set of all real numbers except those for which the denominator q is 0, right? So we don't want the denominator to be 0. We already did that. That's a review. There's old videos on that. So you're responsible for 3 things in the beginning. Identifying the domain, identify vertical asymptotes of a rational function, and look for the x and y intercepts. That's like the basics to start off. And eventually we'll look at not just vertical asymptotes, but horizontal asymptotes. And we'll also look at oblique asymptotes. That's all going to relate to these polynomial functions that we're looking at here. So look for a video on that next. So this is like part 1. All right, so let's just dive right in. Find the domain of this. All right, so if you're watching this video and you don't have this document, and even if you do have this document, you should pause and try this problem, and then unpause and then do it. So if you're just watching this and you think you're just going to watch it all the way through and somehow learn something, that would be false. You need to stop the video, try it, then come back and check to see if you did it right. Okay, I'm assuming you're back now. So I'm looking for when the denominator is 0, so I want to make sure that x minus 2, I want to look for values when x minus 2 is equal to 0, but I'm going to use the not equal, so I'm reminding myself I don't want x minus 2 to equal 0. It's just a little helpful hint for me. It's the zero product property. If I add 2 to both sides, I don't want x to equal 2, and I don't want x to equal negative 7, turns out. Okay, but I need to write the domain. And we learned 2 different ways to write the domain. The domain is the set of all x's such that x does not equal 2, comma, oops, something in there, and x does not equal negative 7. So that would be in set builder notation or set notation. The other way would be to write it in interval notation, which would be from negative infinity all the way up to negative 7, union negative 7 to 2. These parentheses mean we're not including those points, right? We don't want to include 2 and negative 7. Union 2 to infinity. So that's just, you could write it either way, right? Depending on what your teacher requests. Okay? So that's just the domain. That's a review. Find the vertical asymptotes, if any, of this graph. Now it turns out it's really closely related to what we just did, except there's like a little key piece that's different here. We still are looking at the denominator. We're going to look at the denominator. We're going to look at when the denominator, what values of x make the denominator 0. And we already know that. So we know that when x is 2 and then when x is negative 7, we're going to have 0 in the denominator. So it turns out there are vertical asymptotes at x equals 2 and x equals negative 7. Okay? So if you forgot what an asymptote is, it's that dotted line we had when we wrote a graph that the graph approaches. So I'm just going to show you on a calculator what this graph would look like. We can kind of double check. So I'm looking at this one. I'm using my old school calculator. We've got 3x plus 5, right? So that's my numerator. I'm careful to put it in parentheses here. Divided by, I want to divide by this whole thing, so I'm going to group this whole thing in parentheses. X minus 2 and x plus 7, closing my parentheses, and then I want to look at the graph. And I've noticed, actually, because I did this at school, that it didn't show this little line right here in some of the other calculators. So when they update the operating system in these calculators, sometimes it looks a little bit different. Even the y equals screen has tended to look different. So they update them a little bit, and I'm noticing in mine it actually has a line right here, which is actually not good. That line, it looks like a little diagonal, but the calculator is not able to properly show that. But there's a vertical asymptote, like we said, at 2 and negative 7. So right about here, negative 7 is where there's an asymptote, and right here at 2 there's a vertical asymptote. So it's that dotted line that we had in the graph, and that's for like a separate lesson. If we're just trying to identify them algebraically, we just need to look at the denominator there, but that's not the whole story really, because it turns out that just because there's a factor of x minus 2 on the denominator doesn't mean that there's automatically a vertical asymptote at 2. So what I mean by that is, I'm going to write some directions for how to find vertical asymptotes, but I'm going to put a clause there. So look for x values that make the denominator equals 0, right? But if there is a repeated factor in the numerator, the asymptote is really a hole. All right, so it's really a hole in the graph. Sorry about that. It's really a hole in the graph. And what that looks like, again, if you were to look at this in your graphing calculator, you would have, so let's just think of an example. Let's say that x minus 2 was repeated in the numerator. So x minus 2 divided by, let's say x minus 2 times x plus 7. So that would be like if I change this top factor to x minus 2, that's what it would look like in the calculator. And we would anticipate, if we didn't look hard enough, to say, oh, there's going to be an asymptote at 2 because that's when the denominator is 0. Well, that's not really true because we've got an x minus 2 up top, and those cancel to make 1, but you still can't plug in positive 2 into this function here. And so what the graph looks like is just this, right? There is no other asymptote over here. In fact, if you were to do second trace and go to value, and I asked the calculator, what's the value at 2? It would tell me nothing, right? There is no value at 2. So there's a hole in the graph. It's just an open circle if you were to graph that. All right? That's probably the hardest piece. So just remember those things. Look for x values in the denominator that's 0, but also make sure there's not a repeated factor that causes a hole in the graph. All right? That's really all you do for vertical asymptotes. The last piece is to find the x and y intercepts, and that's actually pretty easy. There's a little bit of a review. You've essentially done this with every other thing you've done in math. X-intercepts, let's just start off with that. So an x-intercept, so x-int would be when y is 0. So I always write this first, so that I know I'm getting this value, and 0 will be for y. So what I do, 0 goes in for where y would be. All right, and then we have the denominator is the same. And I need to solve for x. So I need to multiply both sides times the denominator, which means I multiply times x minus 2. I'm going to write really small, x plus 7. Right, that's going to cancel there, and then I multiply the other side times x minus 2 times x plus 7. I'm writing really small, kind of sloppy. This whole thing times 0, so it's times 0. It's not a subtraction or anything like that. 0 times anything is going to be 0, so that's still going to be 0. So we're left with 0 equals 3x plus 5. Well, that's simple. So the shortcut really would be just look at the numerator, right? Just look at the numerator and set that equal to 0. Because what you would really do is multiply times the denominator, and then it's going to cancel out anyway. So we're just solving this for x. So subtract 5, negative 5 equals 3x. Divide by 3. So you get x equals negative 5 thirds. And so your x-intercept is negative 5 thirds, right? 0. That's your x-intercept. Simple. You've done that a million times before. Okay, so now let's work on the y-intercept. If you want to pause the video again and try it, do it. All right, welcome back. So y-intercept. We've got 0 for x is what we're plugging in, which is really simple. So we're going to have y equals 3 times 0 plus 5 all over 0 minus 2, 0 plus 7. What's that equal? 3 times 0 is 0. That's 5 on top. Negative 2 times 7 is negative 14, so my y-intercept becomes 0, comma, negative 5 over 14. That's how you find the y-intercept. Now this is, again, a little bit of a baby step. That's what's going to help you form a graph. You're going to be able to identify vertical asymptotes. You're going to be able to find the x-intercept and y-intercept, and you could actually plug in other points besides 0, depending on what your asymptotes are, to figure out what your graph looks like without using a graphing calculator. Good luck.